So now we will see the Jmag Express. So when you are opening in Jmag Express, so this is how your Jmag Express setup will be there. So you have to select the type of motor. So if you are using a IPM or a SPM or outer inner rotor permanent magnet type, outer rotor type or inner rotor type or induction motor. So now I am selecting induction motor. So we will choose in permanent magnet type of BLDC motor. So I am choosing outer rotor permanent magnet type of a motor, and I have to select what are the type of rotor structures. So we have spoke type, crystal type. These are the types of standard type of rotor structures will be present. You have to select, and then you have to select type of stator. So we have different types of structure of your stator will be present. So here I am going to select a parallel side of teeth with arc and teeth and back iron will be present. So this is what I am going to select for an structure. So rotor structure will be a standard RAP, and then stator structure parallel side of teeth I am selecting. So next I can select the scenarios. So what are the different behavior? That means I am going to design this motor, BLDC motor, and I am going to analyze the characteristics. So what is the efficiency of my motor? So I need to know, identify the efficiency of the motor, and then machine characteristics like temperature dependency, efficiency, how I am getting, and then main thing is cogging torque of my motor. So these are the parameters which I am going to select, and I am going to find the behavior. Okay, so this is the second step you have to do. So another method is, so if you are having any geometrical method, if you are having predefined template you have designed using your other softwares like CAD softwares, you can import the geometry by using an import geometry library, or you can use a CAD data to import the already predefined data into the Jmag Express is also possible. Okay, so this is a mechanical design. If you need to analyze the stress, you can select the stress. And insulation design, electrical braking conditions you have to, if you need to analyze, you can use. So customization also possible. So these are the parameters I am going to use, and you have to get select OK. So if you are selecting, so it will import the model. So now I am selected the predefined templates which is available in a Jmag Express, and it will collect all the template based designs into the Jmag Express. So it will take some few seconds, and once it is applied we can directly change the values. So if I am having, so for example, if I am having an BLDC motor for an outer inner radius of 50 and outer radius of 100. So this is the structure. That means inner OD and outer OD I have to define, and I have to give the materials. So we will see how we are going to give the materials. Now, now I have get the material. That means I have selected the rotor. This is my rotor and this is my stator. So this is the structure I am going to design. Okay, so for this I am having outer diameter. So as I already said, I am having 100 mm is the outer diameter, so I can change the outer diameter. So stack height is 200. Stack height means it is total height where I am so this is the stack height. So stack height is, sorry, 50 mm is the stack height for me. So normally you, this all the parameters are off, so you can double click and you can change the values. So if I am giving 12 poles means you will get the total of 12 poles here. For slot I am having 24 slot, so I am giving 24 slot. Okay, so gap I can redefine the gap, either I can give a fixed or free gap. So now I am giving free gap of 0.8 mm as a gap, and outer diameter, so this is the overall diameter, and in that my stator is present at 80 mm. So I am giving that all the parameters. So defaulted diameter is 80 mm, so I am taking 80 mm because the outer surface is 100, but my stator is starting at 80 mm. If you are going for rotor, it will be around 820, that is at 100 mm is the rotor surface I am having. So these are the parameters. So what is my stator? If you are designing in stator, so you can see that what is the stator outer diameter, and then the stator inner diameter, and then tooth tip is here. So now you, if you are zoom in, you can see the tooth tip. So this is the tooth tip. So I am giving 0.8 as a tooth tip for my system. So if you are changing this tooth tip, so what will happen means you will have a flux fringing will be more higher, and you will have a leakage of flux will be more ready. So if you are varying this tooth tip, you will have a different entities of changes in your magnetic flux will be present. Okay, so let me see what will happen if I am changing 0.75, and these are the general parameters of my dimension. Okay, now I have given all the dimensional and diameter parameters. Now I am going to select the materials. So here you, if you are selecting the material, this is the dimension, this is the material. So if you are selecting the material, so for stator I am using copper, for rotor I'm using 50 the soft magnetic materials. In soft magnetic materials, steel sheet. So in steel sheet we have different types. In that JFE is the normal sheet we have. So in that I am selecting 35 JN270. So if you are double clicking, you will get the magnetic maximum flux density value of particular steel material, and then their magnetic electrical properties and conductivity property, mechanical properties. So all you can change or you can use this material. Okay, so I am selecting that and giving OK. So now my material is getting selected. Okay, so similarly for your rotor, if you need to change, you can change, but I am using 58,000 is the steel material I am using for magnetic material. So I can change. So if you need permanent magnet material, so in that you can go for any type of magnetic material. So I am using ferrite type of magnetic material, means you can use, otherwise you go for NDFEB means. So you have two types, tender type and bonded type. So I am selecting an bonded type of material. In that I am selecting ferrite type of material. So that is what I am selected here, reversible type. In that we have different types. In that MQ11 10 kilo ohm is the magnetic. So this is the magnetic material I am selecting and click OK. So you will get the magnetic material. So now my dimension is completed, material is completed. I am going for an winding configurations. So what type of winding I am going to use? I am going to use a round wire. So currently we are so all the new motors are IE4 IE5 classes will have an rectangular wire. So now I am using a round. So diameter of my coil is 0.6 is the diameter, and wire height is 0.8. That means after insulation, so you are getting that value. And number of turns I'm going to use is 50 turns for particular design. So if you are having given the wrong, so it will give you a value. So I have given 50. Now it's saying that wire table have a problem. So normally you can give only 5 or 6 mm, because I am using lot of stators. So it is not possible to accommodate 50 turns in your particular slot dimensions. So it is also, if you are giving a wrong value, it will intimate the status here. Case conditions will be getting highlighted with the red color. So from that you can understand that what is the problem you are getting. So you have to check all the types. So if you are giving any inputs, you have to check the status, whether the motor is can be possible with your particular design. Okay, and I'm giving a winding layer as 2 and maximum coil pitch. So this coil pitch I'm giving as so maximum coil pitch is turned off. So if you are turn on, you can change the maximum coil pitch. So default I am giving as off, and parallel coil is only one. I am using that one. default one, and then drive systems. So what is the drive voltage I'm going to give? So for a BLDC motor I'm going to give 48 volt, maximum current of 35 amps, and what is the maximum speed I'm going to give is 1500. Okay, so these are the parameters. So this is the drive circuit parameters. Operating point parameters means you can set the drive parameters, maximum drive capacity and normal motor operating and speed. It is also possible to change the values. So I am giving the normal operating speed is 1200. Okay, so torque I need a torque of 20 Newton meter means I am giving 20 Newton meter. So it is a just I am giving the value. So this all the values have to be defined based upon your mathematical calculations. So up to I am going to analyze the stress for up to 3000 rpm. So if my motor is operating above 1500 rpm up to 300 rpm, how the stress will be present at your motor can be analyzed. So these are the default temperature, so minimum and maximum temperature and the resolutions what I am going to give for my drive systems I have given, and then electrical parameters. So this is testing potentials structures I am going to use. Okay, so as we are discussing we have seen so this is so a vehicle I am going to use this motor for an vehicle applications. Okay, that means I am having an tire. So what is the drive systems I am going to use? So these are the things which I am going to give. So I am letting it as an default. So if you need any optimization, so as we are discussing about optimization methods in an designer, right? So it is also possible in a Jmag Express also it is possible, as here you can see the optimization conditions. So these are the constraints I have given. Already I have given the constraints, minimum value, maximum values, limits. So now my model is getting run and it is showing the map for efficiency map of my particular motor. So my maximum efficiency point is starting from 82 to maximum of 96 the efficiency which I am getting for particular point based system. So how the mapping of my efficiency and then output power is mapped. Okay, so these are the results. So if you need a graph you can select the graph and you can get the output for different cases. Seeing the graph you can take the study. Okay, so this is the general structure how we can use the Jmag Express. So if you have designed the model you can export to the Jmag designer and you can study the response. Okay, so if you need to change any response cases you can change it here, and if you need to optimize you can use optimization and you can modify the values. Okay.